Submerged arc welding saw process uses heat generated by an electric arc established between a Burray consumable electrode wire and the workpiece. Submerged arc welding is a welding process which utilizes a Burray consumable metallic electrode producing an arc between itself and the workpiece within a granular shielding flux applied around the weld. The arc heats and melts both the workpiece's edges and the electrode wire. The molten electrode material is supplied to the surfaces of the welded pieces, fills the weld pool, and joins the workpieces. Since in this process, welding arc and the weld pool are completely submerged under cover of granular, fusible and molten flux, therefore it is called so. During welding, granular flux is melted using heat generated by arc and forms cover of molten flux layer, which in turn avoids that tendency and prevents accessibility of atmospheric gases to the arc zone and the weld pool. The molten flux reacts with the impurities in the molten weld metal to form slag, which floats over the surface of the weld metal. Layer of slag over the molten weld metal results increased protection of weld metal from atmospheric gas contamination and so improved properties of weld joint. Reduced cooling rate of weld metal and has owing to shielding of the weld pool by molten flux and solidified slag in turn leads to a smoother weld bead and reduced the cracking tendency of hard-rolled steel. The commonly used accessories in SAW are travel equipment, flux recovery units, fixturing equipment and positioning equipment. Travel equipment. Weld head travel in SAW is normally provided by a tractor-type carriage, a side beam carriage, and a manipulator. The tractor carriage provides travel along a straight line or gently curved weld joints by riding on tracks set up along the joint, or by riding on the workpiece itself. Some guiding wheels or mechanical, joint tracking devices are used. Side beam carriages provide linear travel only with rated speed travels. They are fixed and the workpieces must be brought to the weld station. Its greatest use is for shop welding. Manipulators are similar to side beams, in that they are fixed and the workpiece side must be brought to the welder. Manipulators are more versatile than side beams in that they are capable of linear motion in 3 axes. The weld head, wire, flux hopper and often the control and operator ride on the manipulator. Flux recovery units. Flux recovery units are frequently used to maximize flux utilization and minimize manual cleanup activities. Pneumatic flux feeding is commonly used in semi-automatic saw and frequently in automatic saw. Flux recovery units may help in the following. 1. Remove fused flux and fused slag behind the weld head. 2. Screen out fused slag and other oversized material. 3. Remove magnetic particles and fines. 4. Recirculate flux back to a hopper for reuse. 5. Flow heat inside the hopper to keep it dry. Positioners and fixtures. Since saw is limited to flat position welding, positioners and related fixturing equipment find widespread use for it. Commonly used positioners include 1. Head tailstock units, turning rolls, or both to rotate cylindrical parts under the weld head. 2. Tilting rotating positioners, to bring the weld-able areas of irregular parts into flat position. Custom fixturing often includes positioners to aid in setting up, positioning and holding the workpiece together. Turnkey systems are available depending on the requirements. Saw features. Very high welding rate. The process is suitable for automation. High quality weld structure. High productivity. 2 to 10 kilograms/hour. Up to 2 meters/min. Bulky, expensive and heavy equipment. Flat and horizontal positions only. Thicker sections 6 mm and above. Mostly ferrous. Materials also Ni alloys. Advantages over arc welding. High density currents. Current density 5 to 6 times more. Therefore melting rate of electrode much higher, speed is high. Deep penetration, min distortion and warpage. 1-1/2-inch thick plate can be welded in single pass. Currents as high as 1000 amperes may be used. Destructive, tensile testing and impact testing. Non-destructive testing and DT, surface inspection, dye penetration and magnetic particle. Internal inspection, ultrasonic inspection, radiographic inspection. High deposition rates. Increase in speed, decrease in cost of weld. Weld shielded from all effects of atmospheric gases. Weld beads exceptionally smooth. Slag easy to remove. No arc flash or glare. Minimal smoke and fumes. Flux and wire added separately, extra dimension of control. Easily automated. Joints can be prepared with narrow grooves. Can be used to weld carbon steels, low alloy steels, stainless steels, chromium molybdenum steels, nickel base alloys. High strength and ductility. Voltage rec is low 20 to 40 V. Welding only in straight line. Flux obstructs view of joint during welding. Flux is subject to contamination th porosity. Normally not suitable for thin material. Restricted to the flat position for grooves, flat and horizontal for fillets. Slag removal required. Flux handling equipment. Weld may contain slag inclusions. Limited applications of the process, mostly for welding horizontally located plates. Long straight welds in heavier material. Vessel longitudinal and circumferential welds. Flange to web joints of I-beams. Flat or horizontal position. Flux has to be supported. Access has to be good. Steel fabrication of structural shapes, e.g., I-beams. Seams for large diameter pipes, tanks, boilers, railroad tank cars, structural shapes, and pressure vessels. Welded components for heavy machinery. Most steels except high-C steel. Not good for non-ferrous metals. Welding low alloy, high tensile strength steels, mild steels, Ni, Munel and many non-ferrous metals. Weld heat-resistant steels and corrosion-resistant steels. Submerged arc welding is used for welding of different grades of steels in many sectors, such as shipbuilding, offshore, structural and pressure vessel industries. Fabrication of pipes, penstocks, LPG cylinders, and bridge girders. Apart from the welding, SAW is also used for surfacing of worn-out parts of large surface area for different purposes, such as reclamation, hard facing and cladding. The typical application of submerged arc welding for weld surfacing includes surfacing of roller barrels and wear plates. Submerged arc welding is widely used for cladding carbon and alloy steels with stainless steel and nickel alloy deposits. Railroad tanks and ship body fabrication. Pressure vessels and heat exchangers.